I know what you're thinking. Wow, you are so coordinated, Mrs. Curtin, with the nail polish, matching the paper, and your shirt, matching your accent nail. I know, I know. I know that especially all the boys in the class are very impressed by my coordination. I'm just kidding. But we're going to talk about properties of radicals, okay, which I'm going to abbreviate with rads, not to be confused with radians later. Anyway, the first property is basically that I can split up a radical if I have things multiplied together. So if A is multiplied with B, then I can take the radical over both A and B separately and multiply them. And same thing with division, right? If it's A over B, I can take the radical over both. We've seen this before. Anyway, our big strategy with finding radicals and simplifying them is to make a tree. So 125 splits into 5 times 5 times 5. There's a pair of 5s which I'll take to the outside and a 5 left on the inside. So the most important thing to note is that if something doesn't have a pair, because this is a square root, it's going to stay on the inside. Whereas if there's a pair, then you take one of them to the outside, right? So there's a pair of 5, so I take a 5 to the outside. Okay, so now I have square root of 50 over square root of 49, which I'm going to split up just like that. Okay, everyone knows as a square root of 49, hopefully, is 7. And then I'm going to make a tree for 50. When we split 50 up, we get a pair of 5s and a 2. So that means a 5 is going to come outside of the radical, and the 2 will be left inside the radical because it is by itself. It doesn't have a pair, right? So it's going to be 5 square root 2 over 7, and that's our final answer. Continue on with another example. If we have a radical with 96 on the inside and then that's over radical 3, I might have started out as 96 over 3 with the radical on the outside. Anyway, we're going to have 96 split up into 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. So I have a bunch of pairs of 2s. There's 2 pairs of 2s. And I'm left with rad 6 or rad 2 times 3. I'm going to leave it split up because you'll see that the rad 3 on the bottom is going to cancel with the rad 3 on the top. Now the 2 times 2 combines to be 4, and I have 4 rad 2 as my final answer. And I also could have started out that problem by just dividing 96 by 3, right? Because if the radical can split up, then it can go back over both, right? So 96 over 3, that could have reduced, and you could have done it that way. Suppose we have 3 rad 6 squared. Okay, note that AB squared is A squared, B squared, but A plus B squared is not A squared plus B squared. Never forget. So we take the square over each, the 3 and the square root 6, right? 3 squared is 9, square root 6 squared, that just undoes the square root, so it's just 6, and then 9 times 6 is 54. Suppose we have the cubic root now. So instead of looking for pairs, I'll be looking for groups of 3. Okay, so 60 splits up into 2 and 30, 2 and 15, and 3 and 5. And then on the bottom, 36 is going to split up into 2 and 18, 2 and 9, 3 and 3. Okay, I don't have any groups of 3. I can't take anything to the outside of the cubic root. Okay, however, I am going to write this as a cubic root of 2 times the cubic root of 2 times the cubic root of 3 times the cubic root of 5. And on the bottom, we have 2, 2, 3, and 3. Okay, notice that I have things that are going to cancel on the top and the bottom. I have those 2s, and those 3s, and I am left with the cubic root of 5 over the cubic root of 3. Now, I'm actually not done, okay, because I hate, or I don't hate, I really have no hatred towards things like this, but I don't like that there's a cubic root on the bottom. That is not fully simplified, and so I have to get it out of the bottom. So if we take this cubic root of 5 over the cubic root of 3, I need to figure out how to get rid of cubic root of 3. Now, normally I would just multiply by rad 3, right? But this is the cubic root, which means I need to have groups of 3, right? Groups of 3, not just groups of 2. So I need to multiply it by another cubic root of 3. And if I do that, I get 3 rad 45. That's 5 times 3, which is 15, times 3, which is 45, over 3. The 3 only comes out because there's 3 3s and not just 2 3s. Okay, very important to remember that. If it's a fifth root, then I need to have 5 of the same thing in order to kind of get it out of the bottom. We're going to talk about 2 theorems now, Theorem 1 and Theorem 2. And Theorem 1 says that if each radical is real, then I have this rule, right? If I have a radical NP, B, right, some number, then I can split this up so it's like radical n over the radical p over b. And then the other thing is if I have, if this radical n radical b is real, okay, if that's a real radical, then I can say that radical n b to the m is the same thing as taking radical n of b and then taking it to the m power on the outside. So it doesn't matter which order you do it, right? So the square root of 2 cubed is the same thing as the square root of 2 cubed. Notice my different emphasis. If you can't notice the change in my voice, then I'm sorry. Take the square root over both of these things in this example. So we have 12 x to the 5th, so it's going to be square root of 12 times square root of x to the 5th, right? I'm going to expand those x's so that there's 5 of them written, and I'm going to circle my pairs. I have a pair of 2's, pair of x's, pair of x's, which means my 2 is going to come out, an x comes out, and my rad 3 is left in, my rad x is left in, and also 2 x's come out, so it's going to be x squared, actually, that comes out, because there's x to the 4th on the inside, so an x squared comes out. And then I just recombine everything. Suppose I have a radical over a fraction. I have y squared over x to the 5th power. So I'm going to take the radical over the top and the bottom. Okay, so I'm going to have a radical y squared on the top and a radical x to the 5th. We remember from earlier, well, first of all, that the square root of y is, or the square root of y squared is just y. But remember, I'm always going to take the positive solution, so it's going to be the absolute value of y. And then it's going to be x squared over root x. Now I have to get rid of that root x, so I'm multiplying it by root x over root x, and end up with the absolute value of y times root x over x cubed. Yeah, just remember that absolute value rule. It's just because I'm taking only the positive solution. That's what I usually do with radicals, so that's all that is. So I have the square root of 9a squared minus 9b squared. I'm going to take the 9 to the outside. So it's the square root of 9 times the square root of a squared minus b squared, which is 3 times the square root of a squared minus b squared. Now you may think, oh, I can keep going. I can take the square root over a squared and then subtract the square root of b squared. No, don't do that. That's sort of like the same thing as a plus b squared equals a squared plus b squared, okay? I cannot split up radicals across a plus sign or a minus sign, only across multiplication division signs, right? So not if it's like a big stop sign when you have a minus sign or a plus sign. Suppose I have the cubic root of 32a to the negative 3, ooh, a negative exponent, and then b to the 4th. Okay, so this is going to be the cubic root of 32, b to the 4th over the cubic root of a cubed. I just take that to the bottom because it has a negative exponent. 32 is 2 times 16 times 2 times 8, and then 2 times 4, and then 2 and 2. I circle the group of 3 because this is a cubic root, not a square root, a cubic root, which means I need to have groups of 3. So this is going to be 2 times, I'm going to take a b out, and I'm going to be left with 4b on the inside. Now notice I put absolute values there. I realize actually that I don't need those absolute values because this is a cubic root, right? And it's okay to have negatives come out of a cubic root. So I don't need to only take the positive solution. And then same thing on the bottom, it's just going to be a, not, absolute value of a, because I don't need it to be the positive solution. Thanks, and good luck on your homework.